Okay, so I'm going to go a little bit deeper than probably, gentlemen, ladies, than we did in geometry and algebra 2 and algebra 2 trig, just because you guys are smart and it's time to know more things. So we are solving triangles today. We're using the gypsy magic of trigonometry to figure out the sides and the angles. And to be honest, in real life, they use this. I am not lying. This is how they determine how far away things are in space. They swear to God they use basic trigonometry. It's crazy. It's how they determine the circumference of the Earth literally, something like 2,000 years ago. It's just basic trigonometry. It's pretty cool that it can do that. But here's what I want to tell you. We're going to second semester talk about what we called in geometry when we were like little babies in geometry. We call these special right triangles. I'm going to trigger some of you, a little trigger warning there. You're going to have a little PTSD about our friend Mr. 306090. I know, see, right there. There it comes. But don't, because we're not doing anything with it today. So don't panic. But we told you they were special. And we told you there were some magical numbers that you had to memorize. And we said, oh, to go from this side to this side, you multiply by 2. And to go from here to here, it was square root of 3. And we told you it was special, right? And you had to memorize it because it was so special. And here's what I'm going to tell you. Sadly, poor little 306090, he is not special. He's just a regular right triangle. Because it turns out that triangle 31, 50, or 60, 59 also has magic numbers. Maybe it's square root of 3.2 and 2.1, I don't know, but it's got magical numbers as well. So does triangle 32 and 58. It turns out none of the damn right triangles are special, right? Sadly, we don't tell that to 306090. He feels good about himself. We don't tell him. So way back in the day, when I was in high school, when I took geometry, in 1978, that's when I took geometry. Don't touch me. This is not, we didn't, you couldn't be certain that a kid had a scientific calculator, right? We didn't know this. So I'm going to tell you how we did trig back in the day. And this, I steal a book from every school I ever taught out. This is the first book I taught out of it. It was published in 1986. And here's what it's got. When it was time to do trig, here's what we would do. We wouldn't just copy the answers from the back. But we did that. But here's what. We looked at this flipping thing right here. And if you look at it, it says trigonomic functions. And if you look really closely, it's got angles, and it's got sine, cosine, tangent, secant, cosecant, cotangent. It looks like this. That's what it looks like. Because I know. Because here's what. These were all of these magic numbers. They're just put into a decimal form and put into a chart. So if we wanted to do the sine of 21 degrees, we'd go to our little chart and we'd find 21 degrees and we'd use that number and we'd do some multiplying, right? Because they're not really that special. They're just, someone just sat down, some weirdo, probably like some friend of Pythagoras, sat down and figured out all of the right triangle ratios. Every angle in a right triangle has its own set of special numbers, not just 30, 60, 90. And you're like, why do we care about that? And here's why. No one wants to do this. Our calculators have them in there. So it's not some little gypsy who's going to be figuring out the math for you that lives in your calculator. Well, it might be, but he just has a little chart and he looks it up and he gives it to you out of your calculator. Here's what's also interesting. When we were kids, when I was a kid, we could sometimes go backwards. I might know that the cosine was 98.6, and I'd be like, oh, what angle does that give me? And I would go backwards. So the table let me go backwards and forwards. So does your calculator, right? Our calculator goes forwards, and it will give us the sides. It will go backwards. It will give us the angles. So that's what we're doing today. We're literally just doing this, but I just wanted to explain to you where it came from. There's no magic. It's just a table. Okay? So here we go. Let's do some. Let's find the sides. You've done this 2 years in a row. It is easy. You will like it. Let's rock and roll. You ready? So I call this, let me make sure it's there, going forward. When we are going forward, we're looking for the sides. So Liam, in order to go forward, the key thing that we need is an angle. We gotta have an angle, right? It's like if we're gonna use this goofy chart, we need an angle. So we need an angle. We got an angle. So I am not lying to you when I tell you, please put baby Sokotoa on your triangle. What that's doing mathematically is it's orienting you in the triangle. You need to have the correct orientation. And the easiest way to do that is to put a little alien, and it's super fun. So here we go. Grab little baby Sokotoa, put him at the angle you are given. Yep. You guys, when I do this, you're going to be like, oh, I remember this. Okay. So let's figure out what we have. So that is 69 degrees. What's this guy? He is opposite. And this guy is adjacent. Right? So we're going to be using, here we go, so, ka, toa. We have opposite and adjacent. That is tangent. So let's write it out carefully. We're going to say the tangent of 69 degrees is the same as x divided by 3. Opposite over adjacent. Right about now, you should be thinking, oh my God, I totally remember how to do this. We're going to move this 3 over. We're done with the math. We're just going to solve this baby. We're going to use our calculators to do it. But you guys got to remember, so this happened in high school too. Not only was there a chart for trig, there was a chart for logs. And if you were lazy and you didn't look very carefully, you would use the wrong chart and you'd miss every problem and we would laugh at you. Same thing happens on your calculator. What do I need to make sure my calculator has before I start these problems? Degree, right? You gotta have that the battery, yeah, and DEG. Right now, make certain your calculator is showing DEG. All of my friends who are using a graphing calculator, those have a tendency to change on their own. So make certain if you're using your graphing calculator, you're in degrees. So here we go. Use your calculator. Hit 3 times or 3 tan 69. I close the parentheses because any open parentheses freaks me out. And hit enter. What did you get? There you go. That's what I'm looking for. That is all right. I got something like 7.8. We're going to the tenths. X equals 7.8. That's how long it is. Does that make sense? Yeah, that makes sense. If I got 700, that would be bad. If I got 3, that would be bad. Yeah, you remember that? Remember that? Hey, let's try the next one. Ooh, what happens if they don't draw it for us? Let's draw it. You guys ready? Let's draw this baby. Just like Jason and I talked about, we're going to put C there. When I got B up here, I got to put A there. You can put A and B wherever you want to put them. I don't care. I know that little side B is here. Little side A is here. Little side C is here. And let's go ahead, and we know that B is 21. And here's what. I'm looking for this guy. Boom. And I know that this guy is 10. Guess what? I just set it up on like that other problem. So the first thing you're going to do, put little Sokotoa on there. Get oriented, right? Figure out what's opposite, what's adjacent, what's hypotenuse, right? I put little Sokotoa where the angle is, right? So we got opposite, and we go to adjacent. Looks like another, looks like a stupid other tan one. Is that right? That's disappointing. No, not, yeah, 10. Tan of 20, is that right? I did this problem in the last class, and I did the whole thing wrong, and they said nothing, and now I hate them. So if you know anyone in first period, I hate them. And if you're a parent of someone in first period, I hate your students. They let me do the whole thing, like the whole thing. And then finally I'm like, oh my God, it's sign, not tan. And they're like, yeah, we knew that. And I thought, does this look right? Does it look like I'm doing it right? Please, God, tell me. On that, do you see where that clipboard is on my desk? Slap it right there. So 10 times
closer.
10.
Oh, got my
Okay, so there's me being pissy. You're asking for an extra day? Don't just draw the money. Like, at least give me the courtesy of following along. If you really feel like I need extra time, because I don't even need to listen to what you have to say because I'm so smart, then take the flipping test.
I'm listening.
Bring the thing down.
I'm listening. No.
Angry face. Did you guys get shoot, now it's gone. 3.8?
No.
3.8?
No.
Oh, we're gonna do one more of these ones. This is a little tricky. Give this bad boy a try. Move him up a little bit. This one's tricky. I'm gonna give you a little hint. You're gonna have to do that diagonal flip you had me last year. You're gonna get a variable in the denominator. We don't like that. And do a little flippy thing. If you're like, what is she talking about? I'll talk to you about it in a second. Get your little SOHCAHTOA. Opposite hypotenuse. Sine 26. Here's the issue, my lambs. I don't like an X on the denominator. So I'm going to show you a cool thing that maybe in algebra 2 trig you don't know about, but most of you do. So here's what. Do you guys agree that 4/8 is the same as 1/2? Is everybody okay with that? No one thinks I'm lying to them. Watch what I can do. The law of proportions lets me switch things diagonally. So I could put this 1 here and this 8 here. Look at that. That's still good. I'm still totally okay. You're allowed to flip things diagonally. And you're like, Miss T, how does that help? Well, let's make that into 2 fractions. Now flip diagonally. Get the X on the top. Put that sine 26 on the bottom. Then this problem is easy to do, right? So flip them diagonally. You can't flip side to side. That's cheating. Diagonal flip. Guess what? This is the one where you divide. This is the one where you divide. So 4 divided by sine 26. If you got an answer, you're like, share with your neighbor. See if they believe you. See if your calculator lied to you. Here's a hint. It's a hypotenuse. It better be pretty long, right? It better be bigger than that 4. Did you guys get 9.1? Are we good? Yeah. Oh. Okay, moving on. Again, if you're like, why is she going so fast? Y'all have done this. Skip number 4, it's boring. I don't want to do it. So here's what. We can also go backwards. Now listen, going backwards is this. Write this down. Missing angle backwards. We're going backwards. In other words, here's what's going to happen on our computer or calculator. We're going to get this, and we're going to go backwards to this, right? We're going backwards. Our calculator can go backwards, but we got to tell it how to do it. So here's what I need you to write down, just to remind yourself. Backwards is when you're missing an angle. So when we're looking for the angle, if this is sine, here's what sine backwards says. Sine backwards of opposite over hypotenuse will give us the angle. We're just going backwards. If we ask it to do cosine backwards, that means we know the adjacent and the hypotenuse. We put it in backwards, inverse, it will give us the angle. And if we say, hey, I know the opposite and the adjacent, can I do it backwards? And your calculator says, yeah, I can go backwards. How do you go backwards on your computer or your calculator? That little negative, that little second button. Y'all see it? It'll get you to that stuff right above sine, cosine, and tangent. Super easy. So here we go. Let's do it. Here's our triangle. I'm going backwards because I'm looking for the angle. Fellow theta, that's what I'm missing. Put SOHCAHTOA at the angle you're missing or the angle you have. But get yourself oriented. SOHCAHTOA is right here. Here he is. What he does is he gets us oriented. So let's think about what's going on from, now he's looking like a bug. What he's got going on right here is adjacent and hypotenuse. So we're going to say to this nice little guy, little calculator, if I know adjacent and hypotenuse, cosine, can I go backwards? In other words, the cosine backwards of 10 over 13 will give us our angle. So do that. Do it right on your calculator. It's really straightforward. Cosine backwards, 10 over 13, close those parentheses, hit enter. It's as easy as that. Second cosine, that's cosine backwards, 10 divided by 13.
What'd you get, Mr.
I got 39.7. You know what? 39.7 degrees, because it's an angle. Easy? I like these. I like these. Try one on your own. Try one on your own. Oh, sorry. If you're ready, go to number 6. If you're ready, you can go to number 6. Here, I'll move that up for you. Do number 6 if you got it. You guys are doing great.
Thank you.
I love Trey. It's clean. It's so clean. And I love a calculator. I like when I don't really, okay, this is bad to say I'm a math teacher. Because I really like to do that much math. I don't want to figure it out. I just don't want to do like 18 steps. Maybe that's why I'm going to be a math teacher. Okay, we're doing number 6 if you're already there. Again, I'm not kidding. I know it sounds stupid. What SOHCAHTOA does, it seems babyish. It just orients you. It just gets you knowing where the hell stuff is located. So I got another adjacent and hypotenuse. Looks like another cosine. Cosine backwards. 8 over 10.7 equals our angle. Nice and easy. Second cosine. Oh, 8 divided by 10.7. You guys get like 41.6? 41.6 degrees. Last problem, best problem. Here's what. Now that we're in pre-calc, we do a thing called solving the triangle. Means find everything. Find everything. But you know what? It's not that hard because you know a lot. You know a bunch of stuff before you even start. So let's do this. Let's take what we know and put it over here, right? So angle A, we already know him. Angle A is 31 degrees. Yay, 31 degrees. That's done. Angle C, we know that's 90. Hey, you guys, without doing any math, do I know? Yeah, what is angle B? 59, right? Because they just add up to 180, right? So I don't even have to do any math there if I don't want to. And if you want to put them right here, you can. You don't have to, but if you want to. And now I also know AC, right? So you know what? All I'm missing is 2 parts. So you have an option. You can put baby SOHCAHTOA up here, or you can put baby SOHCAHTOA down here. I don't care. It works either way. You decide. So here's what you want to do. I'm going to put baby SOHCAHTOA. I'm going to make him blue. Look, there he is. I'm going to put him here. I'm gonna start by finding this guy. That is opposite, that is adjacent, I'm good to go. I'm gonna say, now I'm going forward, right, because I'm looking for a side. So opposite and adjacent, that's tangent. Tangent of 31 is x over 9. Bless you, bless you. Nice and easy. Clear that out. I'm just going to say 9, tan, 31. I close the parentheses, kind of makes me worried. I'm getting like 5.4. Did you guys get that? Yay, yay. Okay, last one, and I'm shutting up, and you're going to do it. I need you to find this guy. I need you to find this guy, right? You can use anything on the triangle. It's fair game. You want to use 9, you can. You want to use 5.4, you can. You want to use 59, I don't care. Use whatever you want. But find your last side. It's the hypotenuse, by the way. Hey, I forgot it was a SS day, so I wanted you guys to have time in class to work on these, and you don't. So just do the odd ones. Just do odd.
Wow, I'm really having fun.
Is it 10 points? 10.4? Is it 10.4?
10.5.
10.5.
What?
Round it correctly.
What's
What is the answer for that? 30 or 80?
everyone?
Oh, you did that.
Yeah.
And you could totally do that. You could totally do that. I would have done it by or sign. I would have done sign.
So I guess when we get it wrong, we put square root.
No, that's not what it is. I would have liked that. I would
It's
have.
a lot quicker.
Yeah, I don't like doing this 5.4 squared, but that would have been. Yeah, so these guys over here, you know what they did? They did a squared plus b squared equals c squared. That's totally fine. That's totally fine. However you want, it all works. Weird, but fine. No, I know. I thought I was able to fight it. You say inappropriate things. You freak me out. Okay, but I feel like I'm in court and they may say something weird in the question. It goes on that last one. That's fine. Thank you. Odd ones. Give me odd ones. I'm done. Yeah, I'm going to check a homework really, really